engineered iron, continuously cast from Dura, an advanced material technology for today's competitive and fast-changing manufacturing environment. Dura, a process that speeds up the making of ferrous parts, producing gray, ductile, and alloyed iron bars that can be machined directly at less cost. Dura, located 60 miles northwest of Chicago, is a division of Wells Manufacturing Company, an innovative leader in the production of high-quality engineered iron products. Dura, its state-of-the-art continuous casting process saves time and money. It does away with the need for pattern making, and it improves machinability and eliminates scrap by providing a uniformly dense, fine-grained structure free from porosity, sand, slag, and other defects. Dura is the world's largest producer of continuous cast iron and the first company to introduce this process to North American industry. With its state-of-the-art production and quality-assured technology, Dura can give you what you need in near-net shapes and special alloys. Our products can more than compete with both traditional iron casting and other materials such as steel, bronze, and aluminum. At Dura, the emphasis is on quality. Every one of our products is subjected to 37 different major quality control checks as it moves through the production process. Quality products begin with quality raw materials. Brought in by truck or rail, raw materials are stored in individual bins, segregated by size and alloy. Storage bins are specially designed to dry material with warm air from a unique heat recovery system. Up to 3 different raw materials can be automatically weighed and moved into a charge bucket for transport to the melting furnaces. Dura operates 3 25-ton and 2 9-ton furnaces that can produce a variety of metals, up to 100,000 tons annually. And because they're coreless induction furnaces, tighter control over the iron's chemistry can be maintained. A computerized charge calculation gives the exact weight and type of raw materials and alloys needed for a consistent and most economical charge. Also, because relatively small amounts of iron are charged and tapped from the furnaces, there is virtually no variation in chemistry throughout the melting process. This quality consistency also means cost efficiency. As much as 90% of raw materials ultimately end up as finished product. Also, for ductile iron, tightly controlled charge materials permit the production of low manganese, low sulfur Dura products with optimum as-cast properties. To assure consistent quality during the melting process, a spectroanalysis of every tap is taken. A carbon pin test analyzes carbon and sulfur content. And because the proper metal temperature is critical to meeting metallurgical properties, the temperature of the iron is monitored continuously. As the iron melts, impurities rise to the top of the furnace in the form of slag, where they're removed prior to tapping out. After the impurities are removed and the chemical analysis is complete, and when the molten iron has reached the proper temperature, the furnace is hydraulically tilted, tapping the metal out into a transfer ladle. Each transfer ladle is brought to another quality station. Here, the metal's chemistry is tested in the same manner as it was when it was in the furnace. Impurities are again slagged off. And once again, the temperature is precisely measured and recorded. When the chemical makeup is verified and the temperature is right, the molten iron is transferred to a holding furnace to begin the continuous bar-making process. 7 production lines are available to produce bars in varying shapes, sizes, and metal grades. Metal is added to the holding furnace at predetermined intervals to maintain a constant level of iron in the casting machine. This constant level permits gases and impurities to rise to the top of the holding furnace. And since bars are pulled from the bottom, porosity, slag, and other tool-wearing inclusions are virtually eliminated. From the holding furnace, the metal is pulled through a water-cooled graphite die, which determines the size and shape of the bar being produced. The die is made from a special grade of graphite and is a critical part of the Dura process. The dies produce bars up to 12¼ inches square, rectangular bars up to 14 by 21, or round bars from 1/2 inch to 20 inches in diameter. But these standard sizes are only part of the story. Durabar's engineers are available to design a custom-made die to meet your specific needs. As metal is pulled through the die, water is circulated through the die cooler, which permits controlled cooling of the molten iron. The outer surface of the metal solidifies into a shape corresponding to the die, but the core of the bar remains molten. Upon exiting from the die, this liquid core reheats the outer surface, dissolving carbides and making for a uniform microstructure and hardness. As the metal exits the die, optical pyrometers monitor its temperature. Temperature at this point is critical, as it determines the speed at which the bar can be pulled to assure proper microstructure. From the exit of the die, the bar-shaped metal travels some 80 feet, which allows the bar to cool and solidify completely. At the proper length, the bar is notched with an abrasive saw and broken off automatically by a hydraulic ram. Bars are cut in standard lengths of 72 inches, but specially ordered bars are available up to 25 feet in length. During production, samples of bars are systematically cut for further quality checks by the lab. The samples are polished, etched, and examined to verify proper microstructure. A Brinell hardness test also is performed. Once approved by the metallurgical lab, the bars are visually inspected, color-coded according to their metal specification, and prepared for shipment. The color coding and numbering system allows 100% traceability of bars throughout their final production and distribution. More than 12 million pounds of Durabar in 344 sizes is carried in inventory. For special applications, bars can be tree-fanned, and centerless grinding is available to permit cost-effective machining of small iron parts with automatic screw machines. All tree-panned and centerless ground bars are carefully inspected for tolerance and visual defects. Bars are normally ground to a tolerance of plus 10 thousandths and minus nothing. Durabar. Its quality-assured technology can help you produce finished parts from cast iron more quickly and more economically. The ready availability of Durabar allows machining to be scheduled according to your demand, thus reducing your inventory costs. Continuous cast Durabar also provides solutions for parts that are impractical to manufacture through conventional foundry methods. But Durabar is more than just a technologically superior product. Durabar is a service. Durabar is available through a network of distributors throughout the United States and Canada that can provide a wide variety of pre-processing services. Our distributors maintain a large inventory of bars and tubes in a wide range of sizes and shapes. In addition, Durabar's technical staff is available to help meet your needs. We'll help you design and test a Durabar product that's right for you, and we'll work with you to address any machining considerations that may arise. From bushings to valve bodies, the possible applications for Durabar are endless. Whether it's gray or ductile iron, Ni-resist, or Aus-tempered ductile iron, our HTN, look to Durabar for ferrous parts unmatched in cost or quality. Durabar, the technology of tomorrow, ready to help you compete in today's changing manufacturing marketplace.